Okay, so yeah, still on case 3. This is still on theorem 1. This is case 3. Remember, you are watching Sakachio at the work. So let's go. So here we have, oh man. So here we have that, as I advised, find the center. Center here is x. Simply x equals 2 times, what is the circumference? 60. So x is equal to 2 times 60, which is 120. I don't like when students complain you don't know maths. You don't know maths, you don't like maths. You must like it by 5 by force. This is simple. Understand the theorems. You can solve the problems. Once you have a deep understanding of the theorems, problem solving is just, you can solve as much problem, but you need to understand the theorem. Continue. No much talk actually. So here we have that y equals 2 times 35. So y is equal to 2 times 35 is 70 degrees, I guess. Correct. So here we have that our x will be 80 divided by 2. I know this one will confuse you, sorry. Let me do it where you understand. What is the center? The center is 80. Good. Equals 2 times, what is the circumference? X. So have 2x equals 80. Divide by 2, divide by 2. This can take this, so my x is equal to 40. Yes. So we're going to solve miscellaneous problems on circle theorems. Case 1, case 2, case 3, and theorem 1 in general. Okay, so we're going to note some facts before we start solving general problems on theorem 1. So what are the facts we need to note? We need to note that in this theorem 1, we have case 1, which says that like this. If here is x, there will be 2x. We have case 2. If here is x, outside here will be 2x. We have case 3. If here is x, then here is 2x. This is the first thing you need to note. Case 1, case 2, case 3. And also, in any circle, you have a line that runs from this center to the circumference is called the radius. The circumference is called the radius, and they are always equal. You should note that. Then this is something you need to note. Then also, if you are given a circle and you have a triangle where here is the center. Now, this triangle is always an isosceles triangle where these base angles are equal. So if I have 30 here, it means that here must be 30 because the base angles are equal. Those are, I think, basically this is a fact you need to note. So let's go into problem solving. So we'll move on. So this is under theorem 1. And it's actually simple. So if you notice, you can name this angle A, O, B, and P. Now, note in triangle A, O, B, x is equal to 50. What is the reason? Isosceles triangle, because this place is equal to this place. Then we'll continue. So we have, since here is 50, we'll have that 50 plus 50 plus m give me 180. Reason: sum of angles in a triangle. So have m plus 100 equals to 180. So that m is equal to 1 minus 100. M is equal to 180 minus 100 is 80. And since we now have that the center is 80, remember theorem 1 which says that the center is 2 times the circumference, which is n. So have that 80 is equal to 2n divided by 2 divided by 2. This can be this. So have n is equal to 2 into 80 is 40. So have our values. X is 50, m is 80, and n is 40. Move on to the next problem. Next problem is also the same thing. We note that x is equal to y because it's isosceles triangle. X is equal to y. I can name it P, O. Here will be Q. Here will be, let's say, M. So we can say in triangle POM, x is equal to y. Reason isosceles triangle. Then we can continue. We now say x plus 100 plus x, because this is x plus 100 plus x is equal to y, is equal to 180. Sum of angles in a triangle. We have 2x plus 100 plus 180. X is equal to 180 minus 100. 2x is equal to 180 minus 100 is 80. You can write, yes. So 2 into 80, x will be 40. X is 40. Hence, x is equal to y. Therefore, y is also 40. So to find k is simple. Angles at the center, which is 100, is 2 times angles at the circumference, which is k. Therefore, my k will be 100 over 2, which is 50. So this is the third problem. So I'll give this as class form. So try out this one. We are given 60. You can use this to find this. Then you know what happens here and here because of this angle. And you can find also y using cases that we have solved. You can name it M, O, N, Q. Then you solve. So we'll go to the second part. Okay, so we have a problem here. It says we should find the value of y, x, and z. Now, one thing about solving second theorem problems is you need to bring your imagination. You have to employ imagination. Now look at this problem carefully. I want you to journey with me. Can you see something like this in this diagram? Okay, let's name it A, B. Here is O, normally center O, C, and D. Now, can you see something like this? Can you see A, D, C? Here is O, and here is X, and here is 150. Now, can you see something like that? If you can see something like that, it's simple. From here, you can get that X is simply, which is the center, is 2 times the circumference, which is 150. X 2 times 150 is 300. So we have here to be 300. Now, in the same problem, we have here to be y. Here, we have y here. And we can use the case of angles at a point, which is x plus y equals to 360. Because of angles at a point, we write it angles at a point. Now, my y will now be 360 minus x. Y will now be 360 minus, what is my x? 300. So my y will now be 60. Now, you employ your imagination again, and we have, in same circle, we'll have something like this. If you can see, A, C, B. Here we have 60 degrees, and here we have Z. If you can check. So we have from here, we have our center is 60 degrees. Our circumference is Z, so we have 2 times Z. So we have that 2Z is equal to 60 degrees. This can take this to give me that Z equals 30 degrees. And that's just it. So whenever you're given a problem, try to redraw the problems and check where it is given, so you can easily find the problems. So this is it for this case. Okay, so finally, this is your classwork. Attempt this, find the value of W, X, and Y, find the value of X, Y, and M. I'll meet you in circle theorems 2. I'll explain circle theorem 2 in our next class. Thank you.